In this section, you are going to learn about the secant x and secant inverse x functions. At first, let's talk about the function of secant x. As you can see, this is my x-axis and this is my y-axis. The values that I'm considering on the x-axis are pi over 2, pi, 3 pi over 2 on the right side of origin, and on the left side of origin I'm considering negative pi over 2, negative pi, and negative 3 pi over 2. The values that I'm considering on the y-axis is 1 and negative 1. Before I graph the actual secant function, what I would like to do, I would like to draw some vertical lines. So I will draw the vertical line passes through the angle multiple of pi over 2. So you can see these are my vertical lines with the dotted line. Now let's graph the secant function. So if I graph the secant function, as you can see, this is my graph of secant function. As you can see, secant function does not exist between the value negative 1 and 1, and secant functions are also not defined at the angle multiple of pi over 2. So see, if I consider this vertical line, secant function is not intersecting the vertical line at any point. Technically, secant function is not defined at pi over 2. So the domain of secant function is all the numbers except the multiple of pi over 2. And the range is, as you can see, the secant function does not lie between negative 1 and 1. So when we find the range of the secant function, the value should not be between negative 1 and 1. So the range of the secant function is negative infinity to negative 1. And then we are excluding these values right here, and then we'll start again at 1 to infinity, including the end values negative 1 and 1. Or in other words, we can say that the range of the secant function is r minus negative 1 to 1, and the periodicity of secant function is 2 pi. Let's talk about some more properties of secant function. As you can see, this is my quadrant plane. This is the angle 0, this is angle pi over 2, pi, 3 pi over 2, and 2 pi. From 0 to pi over 2, this is my first quadrant. From pi over 2 to pi, this is my second quadrant. My third quadrant is from pi to 3 pi over 2. And my fourth quadrant is from 3 pi over 2 to 2 pi. The value of secant is positive in the first quadrant, and the values vary from 1 to infinity. The value of secant is negative in the second quadrant, and the value varies from negative infinity to negative 1. The value of secant is negative in third quadrant, and the values vary from negative 1 to negative infinity. And the value of secant is positive in fourth quadrant, and the value varies from infinity to 1. Now it's time for us to talk about the function of secant inverse x. So as you can see, this is my x-axis and this is my y-axis. The values that I'm considering on the positive y-axis are pi over 2, pi, and 3 pi over 2. And the value that I'm considering on the negative y-axis is negative pi over 2, which is over here. Now let's grab the secant inverse function. If we grab the secant inverse function, our function will look like this one. So as you can see again, the function is not defined at pi over 2. So let's consider the domain and range. So the domain of secant inverse function is all the real values except negative 1 and 1. And the range is 0 to pi, excluding the value at pi over 2. Because as you can see, secant function is not defined at pi over 2. If I consider a part of secant inverse function for this range, then that will be this colored part with the red color, and it will be called as the principal value branch of the secant inverse function. So basically, this red colored part of the secant inverse function is called the principal value branch of the secant inverse function.